All right, here we go. Got a few different ones here, and specifically, I want to walk through the two absolute value problems before we really get going. And I think these visual examples will help the understanding kind of make a little bit more sense to you. So I'm going to graph over on GeoGebra, and again, I really highly recommend downloading this program just to be able to play around with the numbers, play around with the graphs, and just kind of see what happens. I think you'll build a really great intuitive understanding of this if you can just get to play with it. And obviously you can use your graphing calculators as well. So here we go. I went ahead and graphed the equation of y equals um, the quantity 2 x plus 2, sorry, x minus 2 squared minus 3, and it changed it away from vertex form, but it was just supposed to be here in vertex form. You can kind of see in the other two examples that we'll use in a second what it was originally. It was, again, the quantity x minus 2 squared minus 3. And so that forms that parabola, and I think we're very comfortable with it. And now, after that, graph this one here in green, and I'll have it up here in just a second. But before we even take a look at it, let's kind of reason through what we think we'll see. So we've got the f of x, or y, is equal to the absolute value of x minus 2 squared minus 3. So our final output is then, we're then taking the absolute value of it. So if we think of this graph as all the outputs, depending on their input, so what would happen if at the very end of processing through that function, we took the output and just made them positive? So these positive areas won't be affected, but these negative areas should be affected. And let's take a look at what it looks like. And I'm hoping you got a good mental picture of it. And here is that function. So notice how the parts that are positive, again, remain completely unaffected. They're still doing their same thing. However, now that there's this bounce back up towards the positive here, it gets reflected. The outputs that are negative are reflected up to their corresponding positive outputs. And so we got kind of a funny looking little parabola there. With just if you were to cut it out with a piece of paper, the top of it got folded back up. Okay, so that's with the entire output being made positive. Now let's think about what if we took the input. Notice here, just the input, the x value, we plug it in, and then that input is made positive through the absolute value function. So what's going to happen here is, well, as we plug in positive values, we should end up with the exact same graph. That shouldn't change at all. It's just once we get to negative x values, like -1, what's going to happen first is that we'll take the absolute value of it, which is 1. And as you go through that function with 1, what's your result? -2. So let's take a look at this one, and hopefully you got a good guess of what that would look like. And here it is. So notice again, the positive x values remain completely the same. Nothing's changed. It's just once we get to these negative x values that first take the absolute value of that number, plug it back into that function, and so we get the exact same mirrored image across the y-axis. And if I'm not positive that this will work right now. Let me try it. If we take the original function and just move it, notice how, oops, let me change that. Oh yeah, it didn't mirror it. If we so unfortunately that part didn't work because I didn't have this mirrored on here. But imagine if we had a parabola looking like this. So actually we can change that pretty easily. If that were y equals, and it's off a little bit by the decimals, but if it was a vertex at -3, -2, so we would change the value here to a +2. And as I'm typing this in, hopefully you can get a good idea of what this will look like now. And there it is. So if we had been graphing the absolute value of this new blue equation, and again, the decimals are a little bit off here, we would have just the positive version, positive x values being reflected. So notice our vertex kind of just completely disappears because that's in our negative x values. We just have this kind of partial piece of a parabola. Now, using all that understanding, let's come back and use it. So if we have, here's our, again, our original function. If we have the outputs being made positive, then the positive outputs remain the exact same. Nothing happens with those ones. Oops, that's too high. These outputs remain the same. The only output that's going to be affected is this one right here that has a -1 y value. And so it's going to go from -1 being made positive up to +1. Now, notice what's happening here on the line, that it's going to the original function still comes down, hits 0 right around -1, that's probably -1/3. And so we still need to have our line come down and hit it at -1/3. It's just now the negative values are made positive, so it bounces back up. Then bounces back to, looks like it's going to be 1/2. And continues on. So anything that was below the x-axis has been reflected up, and it's all been made positive now. Now we can have this exact same function, but underneath the, and I'll draw a quick sketch of it in something like this here. We could have that exact same function by, on the outside of the absolute value, putting in a negative. That we'd make all the outputs positive, and then make all those outputs negative. So you could have something done like that. All right, that's part one. And then I want to skip ahead to right here, and we'll come back to -f of -x. If we are doing the absolute value of our input, notice we'll just take our positive values. Those will stay the same. Nothing's going to happen with those, because the absolute value of a positive number is that same positive number. So that part of the graph would remain unchanged. Now all of the negative values, negative x values that we plug in, would be first made positive. So if I plug in a -1 into the function, I would get a y value of 2. But first it's being made positive. So if I plug in -1, it is got the absolute value of it is made positive, +1, which means our new output is +1. And so we're going to end up with it being kind of mirrored over the right hand of the graph. The positive x values is being mirrored over the y-axis. Okay, there we are. That's again, first make the inputs positive. Positive. Okay. And let's, yeah. So here we are now going to go back and tackle this -f of -x. So if we had plugged in -4 into our function, we got out 0. And so we're going to make both our x and our y negative. So where we had x comma y, x comma y, we're now going to have -x comma -y. And I think this one's probably going to make a little more just intuitive sense. Everything's going to be swapped around, where it was -2, or sorry, yeah, -3, 2. Now it's 3, -2. And you can very easily actually write down a table for those points and go through there. And so I'm ignoring the absolute value function underneath here. It just happens to be on our graph already. All right, there would be our new -f of -x function. So hope that helps.